This is C4 Jan 2006. We'll go through the entire paper very quickly. We'll look at the mark schemes and the examiner's report to get familiar with the paper, so that the next time you do a paper you understand the pattern. Let's start from question number 1. This is an implicit differentiation sum. So this is implicit differentiation. This comes from C3, and for doing this sum we need the concept of C3. So find the equation of the tangent to the curve C, and this is the equation of the curve, and we have a point where we have to find the equation of a tangent. So let's start. We need to differentiate this. Therefore differentiation of 3x squared is 6x, plus differentiation of 4y squared, 4 to the 8 y, and implicit differentiation dy by dx, minus derivative of 2x is 2, plus now this is going to be uv because 6x into y, so this is going to be uv, so it's going to be, the formula is d by dx of uv, it's u d by dx of v plus v d by dx of u. That's the formula. So we can write this is 6x is u, so 6x d by dx of y, so d by dx of y plus y d by dx of 6x. I'm going off the page now. 6x, of course in the exam don't write here, you have to write here, and minus derivative of 5 is 0, and derivative of 0 is also 0. I'll try to write a bit smaller here. So 6x plus 8y dy by dx minus 2, plus inside the bracket, so 6x, derivative of y is dy by dx, plus y, the derivative of 6x is 6, bracket closed, and everything else is 0. So here what can we do is we can take all the dy by dx on one side and take all the other stuff on the other side. So this is 8y dy by dx plus 6x dy by dx, and I'm sending this 6x to the other side, so minus 6x. I'm sending this minus 2 to the other side, so plus 2, and this would be y into 6 is 6y, so minus 6y. Therefore if I take dy by dx as common, it would be 8y plus 6x, and this would be minus 6x plus 2 minus 6y. Therefore dy by dx is going to be minus 6x plus 2 minus 6y divided by 8y plus 6x. Now it's always a good idea if you do the sum and simplify it a little bit. So if I take 2 common, so this would be minus thrice x plus 1 minus thrice y divided by, if I take 2 common here, it would be 4y plus thrice x, and this 2 and this 2 cancels. Now let's go back to the question. So we have to find the equation of the tangent. So for this, for equation of the tangent, we need the C1 concept. C1 concept equation of a line, and you know that equation of a line is y minus y1 equals to m x minus x1, and for that the gradient rule of a tangent is gradient of tangent is equal to gradient of the curve, that is equals to dy by dx. So for this particular question comes from the C1 concept. So let's continue. So in order to find the tangent, we need to find the equation, and for that equation we need to find the gradient, and the gradient of the tangent and the gradient of the curve is the same. So at the point 1 minus 2, at 1 minus 2, dy by dx is going to be minus 3 1 plus 1 minus 3, y is minus 2, putting x and y, divided by 4 minus 2 plus 3 into 1. That would be minus 3 plus 1 plus 6 divided by minus 8 plus 3. That means 1 plus 6 7, 7 minus 3 is 4, 3 minus 8 is minus 5, minus 5 by 4 is the gradient of the curve. So gradient of the tangent would be gradient of the tangent would be the same. Minus 4 by 5 is the same. So equation is going to be therefore y minus y1, this is y1, so y minus minus 2 equals to m. M is the gradient, minus 4 by 5, x minus x1. X minus x1 is this. Let's simplify this. If we multiply this with 5, it would be 5 into y plus 2, minus minus is plus, and this would be minus 4x plus 4. So this would be 5y plus 10 equals to minus 4x plus 4. So now you have to understand, if there is a format, there is an A1 mark here. So they told you to express the answer in the format of ax plus by plus c equal to 0. If you do not do that, you lose 1 mark. Therefore, minus 4x would be 4x. This would be plus y. So 10 minus 4 is plus 6. This is the answer. This is the mark scheme published by Edexcel. So you see that the answer is 5y plus 4x plus 6 equal to 0. So the format is like that. This is the A1 mark. The derivative is m1, a1. You find that, up to that you get 3 points. Then you put the value, you find the values minus 8 by 10. You get 2 more marks for the calculation. You get 1 mark for writing in the format of the equation. So this is the structure of the mark. Remember, this is not how you present your sum in the exam. It just gives you an idea of the mark structure. This is the examiner's report published by the Edexcel people after the exam has been finished. So if you take a look here, this is the general overview, and some suggestion that they give is to be accessible to the majority of the candidates, and there were some excellent scripts. It happens most of the time. Many people do pretty well, some people do bad, and most of the people lie in the middle. So the first question was pretty good. So question number 1, most people could do it, and the presentation was very, very well done. They are putting special attention to the presentation. Now, anything else about question number 1? Question number 1, there is a general idea. It was a little frustrating, however, to see candidates use extra sheets for questions which still had 1 or 2 pages unused. This is something, so don't take extra sheets. They suggest that you do the sum in the proper way, because if you do the sum in the proper presentation, you will not need any extra sheet. Examiners reported that some candidates were under the misconception that pi equals to 180. But remember, pi is not equal to 180 degree. Pi radian is the same as 180 degree. Pi radian means 3.142 radian equals to 180 degree. So pi radian, it's radian, and 180 is degree. So pi is not 180 degree. Pi radian is 180 degree. Pi is 3.142. Then we have individual question report. This question was generally well answered, with most candidates showing good skills in differentiating explicitly, and often subsequent correct working indicated that this was just poor presentation. You have to remember, if you don't present your work properly, you're going to lose points. So if you just think about you're going to follow the mark scheme and the answer matches, still you will not get the full mark. So the presentation is very, very important. Question number 2, this is trapezium rule. Trapezium rule comes from C2. So C2 trapezium rule, this is the concept where for finding the area under the curve, you find using the trapezium rule h by 2 y0 plus 2 into, how many y do we have? This is y0, the first one. So y1, y2, y3. So 2 into y1 plus y2 plus y3, and plus the last one. So the last one is y4. So this is y4. This is the formula for the trapezium rule. The first thing you have to do is fill up the table. So remember, this is C4. C3, C4 usually does the sum in radian mode. So you have to do the sum in radian mode. Y equals to sec x. Sec x cannot be written in the calculator. Sec x is the reciprocal of cos x, the C3 identity. In order to do this sum, you need the C3 identity. So C3 sec theta is the reciprocal of cos theta. So remember that. So when you write this down, reciprocal of cos theta, we can write this using this calc button. We can write 1 by cos theta. So 1 by cos theta, let the theta be x. So press the calc button. So this equation is loaded in the calculator. So if you put pi by 16, so remember they mentioned pi is taken mistakenly as 180 degree. Pi means 3.142 radian, and this is a radian sum. You cannot just take 180 degree. So pi by 16 is the input value, equals to this 1.00000. So we have to express in significant figures. So they have used 5 significant figure. We're going to use that. So 1.00000. This looks a bit strange because 1.000, let me check again whether it's in the radian mode. Oh, the calculator is in the degree mode. This is a common mistake in the exams. You have to make sure your calculator is the radian mode. So let me change the mode to radian mode. Let's try again. 1 by cos x calc. Okay, so pi by 16, pi by 16. Remember to convert the calculator in the radian mode. Now it is more likely. .01959. 1.01959. The next one is pi by 8. Let me press calc again. So pi 3.142 by 8. This one is 1.08239. 1.08239. Finally, let me press the calc button again. Pi by 4. So pi by 4. Remember, a common mistake here was people thought pi was 180 degree and they input in degree. Remember, this is in the radian mode. You cannot input in degree. You have to input in pi radian. Pi radian means 3.142 radian. This is 1.41421. 41421. Done. So next one, use the trapezium rule. So the trapezium rule is going to be area equals, remember, a trapezium rule is always an approximation of the area. That means area means integral. So h by 2, h is like the common difference here, this minus this, this minus this, this minus, and all is pi by 16. So pi by 16 by 2, y naught is the first one, 1 plus 2 into all the things in the middle, which is 1.01959 plus 1.0636239 plus 1.20269 bracket closed, plus the last one, 1.41421. Pi by 16 divided by 2, then multiplied by bracket 1 plus 2 bracket 1.01959 0.01959 plus 1.08 1.08239 239 plus 1.20269 1.20269 bracket closed, plus 1.41421 1.41421 bracket closed equals to 0.88588. So 0.88588. The answer has to be, they didn't mention, so let me write it in 5 decimal places. Question number C, the exact value is given, ln of this integral. So the approximate value of this integral is done by the trapezium rule, and the exact value is this, ln 1 plus square root of 2. So calculate the error percent. Error percent is a concept. Error percent means error divided by exact value into 100%, and error is the difference between exact value and approximate value. Always the positive difference. Error cannot be negative. So this is the approximate value, this is the exact value. So let's find the error first of all. Error equals to ln 1 plus square root of 2 minus 0.88588. So ln 1 plus square root of 2 bracket closed, this one minus 0.88588 negative value, and there is an into 10 to the power minus 3. That means it has a power here, so you can do shift eng so that the power becomes 0. Now it's into 10 to the power 0 means into 1, so there is nothing here. So this would be, you take the positive value, absolute means error cannot be negative, so it would be 0.004506. so that's the error. Therefore error percent would be the error divided by exact value, which is ln 1 plus square root of 2 into 100%. Let's calculate this one. So error is here already, so if you just use this sign, the negative would go away. Write this point 0.004506 divided by ln 1 plus square root of 2 bracket closed, this into 100, so 0.511%, 0.511%. So the mark scheme is 2 marks for filling up this table, M1 for 1 correct, A1 for accuracy. Then you do the trapezium rule, write down the formula out, and there are 2 marks for putting the value in the formula, and for accuracy there is A1. For the percentage error you find the error percent, and there is 2 marks for that. In the mark scheme, so question number 2 says, for a large number of candidates this proved to be a very good question. So very good question, most people in the world could do this, and there were many full mark awarded. However, some candidates had little appreciation of the degree of accuracy they used, and in both part B and C there were some common and serious errors seen. You have to remember, when you do the sum, you have to do the degree of accuracy up to 4 or 5 decimal places. You cannot just take to the nearest number. Although few candidates had trouble with the method of the trapezium rule, the common error in part B was the miscalculation of h. Remember, this is a common error. You remember, for finding h, you go to the next one, subtract the previous one, x2 minus x1 or x1 minus x0. Many candidates divided the x interval by 5 instead of 4, and so remember that the calculation of this was a mistake. And pi is 3.142 radian. The input has to be in radian, so remember the common mistake. Question number 3 is a substitution sum. They have given you the substitution. So this is a C4 sum. First integration sum, integration by substitution. In every C4 paper there will be one substitution sum, one by part sum. So substitution, and the rule is you first substitute the limit, then you substitute the derivative, and then you substitute the expression. So that expression would be in terms of u, the derivative would be in terms of du, and the limit would be in terms of u1 and u2. So you substitute the limit, you substitute the derivative, and you substitute the expression. That's what you do. U square equals to 2x minus 1. Instead of sending this square to the other side and making it square root, it's a good idea to do the derivative as a implicit derivative. So u square is 2u du by dx, 2x is 2, and the derivative of 1 is 0. You can cancel this 2 and this 2, so therefore u du would be dx. So we have found the derivative of this. Now let's do the limit. It's always a good idea to do the limits first actually. So the first limit, the Cartesian limit, x equals to 1, then u square would be 2 into 1 minus 1, which is 1. So u square is plus minus square root of 1 when you send the square to the other side, so it is plus minus 1. Therefore take the positive value all the time for the limit. When x equals to 5, the upper limit is 5, so u square equals to 2 5 the 10 minus 1 9, so therefore u would be plus minus square root of 9, which is plus minus 3. Should be plus minus 3. Therefore u equals to 3. So u equals to 1, u equals to 3 when you have that. Now let's do the substitution. Therefore, so limit is from 1 to 3. Instead of dx, we can write the substitution for dx. Dx is equals to u du. So instead of dx, we can write u du. So this would be u du. Then we have thrice x. Now what we can do is for x, we can actually take this thing. So u square equals to 2x minus 1. We can write u square plus 1 divided by 2 as x. So we can rearrange this substitution, and instead of x, we can substitute u square plus 1 by 2. So 3. So this would be u square plus 1 by 2 divided by square root of 2x minus 1. So this is 2x minus 1. If you send this square to the other side, it will be square root of 2x minus 1. So u is square root of 2x minus 1. So instead of square root of 2x minus 1, I can just write u. That's the substitution. Okay, now we can integrate this u, and this u cancels off. If I bring this constant, if this is 1, this is 3, and this is 3 by 2 u square plus 1 du. So this is u square plus 1 by 2. I just take the 2 outside, and I can bring the constant outside. It's a good idea to bring the constant outside the integral. So u square plus 1 du. A little reminder of a C2 integral. So in C2, actually this is from C1. In C1, the integration for a x to the power n dx was a x to the power n plus 1 divided by n plus 1, and there is a plus c. In C1, the integral of any constant was just that's ax. Integral of a is ax plus c. And in C2, this is called indefinite integral. First introduced in C1, and this is called definite integral. Integral first introduced in C2. Definite integral is integral with a limit. You have some expression to integrate, and all you have is a limit, and the answer would be in number. So this is introduced in C2, and the basic concept of integration is introduced in C1. Let's get back here now. So 3 by 2. Integration of u square is n plus 1 by n plus 1. So this would be u to the power 3 by 3. Integration of a constant. So this is going to be u, and the limit is 1 to 3. So this is going to be 3 by 2. So let's put the upper limit here, 3. This would be 3 cubed by 3 plus 3 minus, be careful about this bracket, this 3 by 2 is outside the entire thing. So then 1 cubed by 3 plus 1. So if you calculate this, this would be 3 cube is 27 by 3 is 9, 9 plus 3 is 12, minus 1 cube is 1, 1 by 3 plus 1, 3 ones are 3, plus 1 4, 4 by 3. So this one would be 12 minus 4 by 3 into 3 by 2. That makes it 16. The mark distribution, the mark scheme is m1 for the substitution, m1 for the derivative. Then you do this, you do the integration, 2 marks for the integration, you find the limit, 2 marks for the limit, and the answer is 16. So we get a clear idea. They have also given an alternate method. We have to worry about that. Let's look at the mark scheme. After that, most candidates chose to use the substitution. That's the best idea because it's a substitution sum, but the answers to this question were quite variable. There were many candidates who gave succinct, neat, totally correct solution. They're stressing on the presentation. Please make sure the presentation is well done, and generally if the first 2 method marks in the scheme were gained, good solutions usually followed. The biggest problem as usual was the treatment of dx. Those who differentiated this implicitly were more successful. So I recommend that instead of making it a square root, you just do this using implicit differentiation, because if you do the square root then you have the power mess and all these things. So that's the idea.